好，欢迎大家回来我们 JSDC 2024最后一场的议程。那我们最后的议程呢，讲者是 Nicolo Ribaldo。Nicolo 是一位热爱开源与 JavaScript 的开发者，目前任职于 Igalia，专注于推动网络技术的进步。那作为 JavaScript 编译器 Babel 的维护者，Nicolo 为全球数百万开发者提供了重要的技术 support。同时，他也是 TC39委员会的代表。参与并推动了多项 JavaScript 提案的开发。今天 Nicolo 将带来的主题为 An Introduction to Source Maps。那我们现在就请大家准备好迎接 Nicolo 的精彩演讲。
Hello, everybody. In this talk, we will go together through source maps, what they are, why they're useful for us, and how they work. I am Nicolo Ribaldo. I work at a company called Igalia, where we develop web standards. I'm a delegate in TC39, the committee that defines how the JavaScript language works, and I maintain Babel, the JavaScript compiler. So yeah, let's get started. So source maps, what are they? Well, they're a tool that lets us solve some problem. So let's see what this problem is. Well, regardless of what we might learn, how we might usually say, well, JavaScript is an interpreted programming language, that's not how we actually use JavaScript. In reality, JavaScript is a compiled programming language. And I'm not talking about things like JavaScript engine having some just-in-time compiler that converts your JavaScript to native code as it runs. I'm talking about something much simpler here. JavaScript is actually an ahead-of-time compiled language. And what do I mean by this? Well, let's just take a look at how we usually write JavaScript applications. We have some files written in some way. It might be JavaScript, it might be, there might be some JSX, some type of notations in it, and then they go through different tools. These tools can transform our code in various ways. We might be transpiling our code, like using Babel, using TypeScript or something else. We might have a bundling step that takes different files and merges them together. And we might have a minifier that still transforms the code in yet another way. So the code that we originally wrote, the one in this example in the users.ts and app.tsx files, is not actually the code that we will be running in the browser, which in this case is the bundle.js file. And well, so the code we write is not the actual code that gets run. And this causes some challenges. For example, how do we debug it? Because the browser, the DevTools, the debugger knows about the code that it's actually running. But while debugging, we would like to debug the code that we wrote and not the code that some other tool generated. So let's consider a little example. We have this file. It contains some class that does some things. And let's assume that we are building it through our build pipeline. And we then run it in the browser. And we get an error. It's telling us that something is not defined. And where is this happening? Well, this is happening inside a function called n in a file main.js at line 5, column 49. Well, okay, so let's look in our file at line 5, column 49. There is nothing there, and for sure there isn't a function called n. Because what's happening, it's actually that this information from DevTools comes from the code that is being run. So we would have to go look at the compiled minified file. And here we can actually find line 5, column 49 that contains a function called n. And here it's where our error is actually coming for. So source maps are what we need now. We got that error from some code that's maybe difficult to read. It's not the code we wrote. Source maps let us, map the code that runs to the original code. So if we apply a source map to this error, we can say, oh, actually, this error is coming from line 11, column 31, which is exactly where in our original code this error should have been. So I've showed some JavaScript examples, but source maps are not just for JavaScript. We might have different types of compiled languages that run on the web. Like JavaScript or TypeScript, we might have some CSS or some like Sass, Less, or another preprocessor that then transpiles some code to CSS, and so we might still want to see the like informations about the locations in the original code. We might also have like some actual compiled for real programming languages like Rust or C that get compiled to WebAssembly. Then we run this WebAssembly in the browser, and we can use a source map to actually pretend that we're debugging the original Rust code in the browser DevTools. So there are tools used in general on the web for whenever there is a transform step that changes our code. So what does a source map look like? Well, if you ever looked at a source map, or like if you have ever seen that your bundler, your minifier is generating a something.js.map file and you opened it, you might have seen something like this. This is what a source map is. It's basically a big file containing a JSON object with some fields. You're usually going to find a version. A version on a source map is always 3. This is because, well, we used to have source map version 1 and version 2, but that was very long ago. And now everybody just implements the same version 3. The source map tells us to what file it refers. So in this case, we know that this source map is for main.js. And then it contains some strings, some information about, for example, what names for variables represent our file, what were the names of the original files that were given as input or build pipeline. So if, for example, we have this src/main.ts file that gets compiled to this /main.js file, the name in our source map will be this /main.js, and sources will point to our src/main.ts, or we might have multiple sources if there is some bundling step going on. Other than sources, we have, well, the contents of the sources that tells us what was originally in those files. And again, we might have just one source, or we might have multiple sources. This source is not actually always there. Sometimes it's just missing, and the assumptions DevTools will actually find the main.ts file on disk rather than the source map. And sources and source content is what tell to DevTools what, well, the original contents of the file was. So that if we, like in this screenshot, it's Chrome, but it will work in any browser. If we open DevTool, look at our code, we will actually see some, in this case, TypeScript code in the browser rather than the JavaScript that the browser is actually running. So we have our original file in the DevTools, but like how does the browser actually know how to connect every single line and column in the original file to the corresponding one in the file, in the JavaScript file that the browser is running? Well, here's where the power and the complexity of source maps comes and help us. If we look at the last field in our source map, we're going to have these mappings. And mappings, it's basically a list of some random looking characters. And like, it's encoded in a way that actually makes it very difficult for us to just look at it and understand what's going on. But there are some tools that help us with this. So if you look at this, it might not be very meaningful, but let's start from what we can easily see. Like we can see there are some semicolons, some commas that separate these various random letters. Well, that's something that we humans can already understand. I can start the coding. So every time there is a semicolon, it actually means that it's defining some mapping data for a different line. So if we were to split our source map, our mappings field on all these semicolons, we can see, oh, this Akasama GBAW-KIF mappings are for the first line of code, and then it's followed by these other mappings for the second line of code, and so on. These mappings are like basically some numbers encoded in base 64, encoded in some way that compresses well so that source map is not too big. And it's basically impossible for humans to manually decode the source maps, but like dev tools do that. There are some tools out there that can help us visualize what a source map is. For example, there is this very helpful source map visualization website from one of the people working on Webpack, I believe, that lets us take any file. You can upload a file with the source map, and it will tell you, oh, look, this maps to that. So I uploaded here the source map I was using in that example, and we can see that, for example, that here, this class underscore amazing pet identifier in the generated code maps to that amazing pet in the original code. Those highlighted in black on screen. And we can see in the bottom part of this website that at line 11, our source map says that column 18 corresponds to line 20, column 18 of the original code. So there were like some semicolons that let us go up to line 11, and then there were some weird letters that once the code gave these numbers out. And tools like debugger, dev tools can decode all of those mappings, and then they can apply all the necessary transformations to the various stack traces that they find. And I really recommend trying playing around. Like if you have some source map here and there, grab those source maps, grab the code, upload them in this website or some other website that does something similar, and try to see what's going on there. So this is what source maps are. We didn't go too much in detail because they can be very complex. But we have now an idea of how browsers use them to help us debugging. But who decides how source maps work? Well, there is a standard here. And it's actually something very new. Source maps have been existing for very long. They've been designed more than 10 years ago. I think V1 was from something like 15 years ago. But until very recently, everything that there was just a Google Doc maintained by two people working at Google and Mozilla that had some information on how the implementation of source maps worked. And then all the various tools or the various browsers, whenever they wanted to implement some source map feature or to make sure they were compatible with each other, they had to look at this Google Doc, try to understand what it said, and then go look at all the other implementations, see, for example, okay, Firefox interprets source maps in this way, so my tool has to generate source map in this way so that Firefox can understand it. And then they would have to go to Chrome and check what the behavior in Chrome was. And it was mostly the same, but then there were all like different edge cases where they behaved differently. And there wasn't a lot of organization. It was mostly just trying, see what works, and trying to copy each other. That was until 2023. In 2023 and then 2024, in TC39, we decided, okay, let's sit together, let's get all the parties interested in source maps in the same room, and let's actually agree on how source maps should work. This effort started a little bit more than 1 year ago, and then a couple of weeks ago, we finally published the first version of the source map specification that you can go find online if you're interested and want to learn exactly how source maps work. So why a standard? Like, why is this important for you all? Why would JavaScript developers care? Like, if things already work somewhat between tools, between the various tools, and they're all already somewhat compatible, why do we need this? Well, we have three main goals here. We had three main goals when we started this standardization effort. We want to make sure that everybody implements source maps the same way, because for every dev tool, for every browser, for every transpiler, you could see that actually they disagreed on everything except of the core semantics. So we needed to make sure that everybody was aligned, that there was a single way of creating source maps and of reading them. And we need to make sure that this specification is complete so that all the possible edge cases are covered and all the possible behaviors are well defined. And we had to align the source map specification draft, what that Google Doc was, to what implementations actually do, so that we have a document describing the reality. And once we have a document that describes how things do, how things work, we have a shared understanding that we can use as a starting point to actually evolve source maps and improve even more the debugging experience. There are multiple proposals for new features in the pipeline that hopefully will make the transpilation steps and all the build pipelines of JavaScript applications even more transparent, so that when you then have some problem, have some error, and need to debug it, it feels even more as if you were just debugging your original code that you wrote in your editor rather than the one that's been generated by some random tool. One of these new features that is now implemented in all browser dev tools and in most tools that generate source maps is ignore list. Ignore list lets browsers skip some files when debugging. For example, you might have a bundler that instructs the browser to skip your node modules, or you might have a transpiler that has to inject some runtime helpers, but then when debugging, you actually want to skip those helpers. You don't want to step into them. And so this basically gives tools a way to mark code as not being actually written by JavaScript developer, and so not actually being relevant when the developer tries to debug their own code. And it's just a new field in source map files that say, so we have this list of sources, but in this case, source 2 and 3 should actually be skipped. We have a second proposal that's very active, and personally it's one of the ones I'm most excited about, called scopes. Source maps allow mapping locations and variable names from the generated code to the original source. But is this enough? Well, the answer is no. There are many cases in which this is not enough. And scopes is what's trying to solve many of these cases by giving us a way to keep track of what all the original functions and variables were. So if we have, for example, a minifier that inlines some function somewhere else, we can actually tell the dev tools, oh, here there was a function, it had these variables. Or we can say, oh, look, these variables have all been renamed, they've been moved somewhere else, but actually they were originally called this way in this function, had these maybe initializers for their values, and basically lets us construct all the functions and variables that were there before transpiling the code. So there are other ideas being discussed as part of the standardization process, and hopefully source maps will improve even more. But this is where we are today, and I hope that this talk taught you something new today. And thank you.
Thank you, Nicolo, for your sharing. Nicolo, could you say hi to everyone?
Yes, hello.
Yeah, and we have some questions on Slido, and we would like to hear about your thoughts. Okay, let's begin with the first question. Should we include source map in npm package? Because the file size is very large. If included, can debug in dev tools? If not, can reduce the npm package size?
Yeah, so I usually include source maps in npm packages for a couple of reasons. One is that, like, yes, they make the npm package bigger, but source maps are then not like shipped to the final user. The browser will only load source maps if the user actually opens the DevTools. This means that while the npm install is bigger, the like final size of the application is not. And the reason I do include source maps is because I hope that my npm libraries don't have errors. However, when there is an error and some user reports a bug and they show me a stack trace, it's much easier for me to just tell them, oh, we run like enable source maps and run your code and give me the new stack trace, than trying by myself to figure out where the error was coming from. Then in cases where the code is not transformed very much, like for example, if you just remove types and so like the generated code looks very similar to the input code, it's not that necessary, but whenever there are more heavy transformations, it's very, very helpful. So like, yes, usually I recommend including source maps in npm packages.
Okay, now we move on to the next question. What's the future between TypeScript and Babel in your opinion?
That's an interesting question because they're kind of seen like competitors. I think TypeScript is here to stay forever, probably, for as long as we have JavaScript. While Babel, maybe one day will like disappear, will not be necessary anymore. However, I'm hoping to see direction as split in between TypeScript doing only type checking because it's what the best at, and other tools such as Babel doing the actual code transformations because they tend to be more flexible, they tend to like be like more powerful, or in some cases give you like better control over your output. Maybe this will not be Babel forever. There are other tools like SWC or OXC that do something similar to Babel, and they will maybe one day become more popular than Babel itself. But I see this as two parallel things. There is TypeScript on one side, and then the various transformers on the other side.
Okay, now we move to a third question. How do third-party Babel plugins ensure that source maps work correctly with transforming code?
So the way Babel, okay, so first of all, due to the way Babel works, there is actually no distinction between like first-party and third-party Babel plugins. They all have access exactly to like the same internal APIs. And the way source maps are served through various plugins in Babel is that, so Babel parses the original code and generate an AST, a tree like representing all the various syntax pieces of the code. And this tree is made of like objects, and each of those objects have a location property. Let's say, so this was the original line, the original column. They also have like some comments, some other metadata. Usually, when plugins transform code, they create and remove some nodes, but mostly they just move nodes around. And so by just moving nodes around, they actually preserve the location information. In cases where actually you are replacing a node and replacing all of its like child nodes, and so you actually need to manually preserve the information, there are some utilities, like there is a utility to inherit both comments from the old node and new node and location information, so that then this is used at the end when Babel generates the output code, while converting each AST node to a string, it can see on each node what the original location was, and so it knows how to generate the source map.
Okay, then next question. Where is JavaScript heading in your opinion?
First of all, thanks to us for explicitly saying in my opinion, because even though I'm very active in TC39, everybody there are people with different opinions on where JavaScript is going, where it should go. What I'm seeing is that JavaScript is getting like different helpful, like small utilities. So like things that normally you would download an npm library for, like we just added some methods on map and set like 1 year ago, and now we're adding a bunch of methods to work with iterators, like all things that you would find in libraries like Lodash, or there is now a proposal adding some more utilities on maps. Or we just shipped some utilities, well, we are shipping some utilities to work with date and times, like Moment or DateFN, but built in the language. So it seems like JavaScript is getting all of these small utilities that replace like small npm utility libraries. Some bigger trend I'm seeing is that different delegates are pushing for JavaScript to become a better language for writing multi-threaded code. Because now that JavaScript is so popular and there are huge applications written in JavaScript, multi-threading starts to be something very interesting when it comes to performance. And I'm hopeful that those efforts will like start having some success in a few years. But JavaScript itself does not evolve in a single direction. So like it's been developed also in many other. There's a little bit more syntax sugar in some areas, but like not that much. But yeah, this answer could go on forever, but I'm hoping that this was like a good summary.
Okay. Due to the time constraint, this will be our last question. When you share the scope proposal, you provide an example with optimized code, inline code. Is there a tool for this?
Yes. So sometimes minifiers do it. Like for example, Terser. I don't think it does it by default, but it has some option to do that. Closure compiler, which is the transpiler / minifier maintained by Google, also can do code inlining. And I believe there is even a Babel plugin, a third-party Babel plugin to do it, but I'm not 100% sure about that. Usually it's like a minifier's job.
Okay, thank you again, Nicola, for your insightful sharing. And we will have to end our Q&A session here.
Okay, thank you everybody, and sorry for the questions we couldn't get to.